Today's lesson discusses some specific types of cells and an exception to the spontaneity rule. A secondary cell is essentially a rechargeable battery. The cell does have a spontaneous reaction that produces electrical energy. When the cell runs low on the required reactants, it can be recharged by applying electricity and reversing the reaction to replenish the supply of reactants needed to produce electricity. When the cell is producing electricity, it is a voltaic cell. When it is recharging, it is an electrolytic cell. In your last lesson, there was a brief explanation of how electrolytic cells could be used in the creation of elements. This procedure can be difficult to use though, because many ionic compounds have low solubility in water, and because water is a stronger oxidizing agent than many active metal cations. A solution that is used to address this problem is melting the ionic compounds so that they can be used as an electrolyte in a cell. For an example, molten strontium chloride can be used to create pure strontium metal. In the molten state, the ions are available to participate in the redox reaction, just as if it was dissolved in water. This process solves the problem of strontium being a weaker oxidizing agent. Here the two half reactions are balanced, and the net reaction is shown. If the strontium chloride was instead dissolved in water, water would have been the strongest oxidizing agent. The reaction that occurred would be completely different. In molten salt electrolysis, metal cations move to the cathode and are reduced to metals, and non-metal ions move to the anode and are oxidized to nonmetals. Electrolysis can be used to plate metals onto other objects. Some extremely valuable metals can be plated onto other metals to protect them or because they have other desirable qualities. These plated items can be produced more cheaply than if they were made of the metal throughout. Electrolysis can also be used to separate water into hydrogen and oxygen. In this reaction, water is the strongest oxidizing agent and the strongest reducing agent. The reaction is not spontaneous, so electricity is required for the reaction to proceed. This is the Hoffman apparatus. It is used to add electricity to a solution. In the case of water, it results in water being broken down into hydrogen and oxygen. There is an important exception to the rules for determining the strongest reducing and strongest oxidizing agents. It is called the chlorine anomaly. If you had sodium chloride in solution and listed all of the entities, you would predict that water would be the SOA and SRA. This would have the same expected result as the electrolysis of water. The expected products would be hydrogen and oxygen. When the reaction takes place, though, a green-colored gas that smells like bleach is produced at the anode. This product is likely to be chlorine gas. This leads us to the chlorine anomaly. It accounts for the difference between the expected and actual results when chlorine ions and water are the only reducing agents. The explanation for this rule is that there is an overpotential. The actual reduction potential required for a particular half reaction and the reported half reaction reduction potential are different. You don't need to know the cause really, but it is important to remember this exception when you are given a solution with water and chlorine ions as the reducing agents. Please complete the October 29th quiz.